Hello everyone, today I'm going to be working through an implicit differentiation question from June 2010. So this question is asking us to find the coordinates of the two stationary points on the curve x squared plus 4xy plus 2y plus 18 equals 0. I'm going to rewrite the equation over here. I'm going to differentiate each variable individually. So x squared differentiates into 2x. 4xy, we're going to have to use the product rule on this because there are two different variables within it. So we'll call u 4x and we'll call v y. The derivative of u will be 4 because we're just differentiating the 4x, and the derivative of the v will be dy by dx because we're differentiating y in respect to x. So the product rule, if you remember, is u multiplied by the derivative of v plus v multiplied the derivative of u. So that's going to be 4x dy dx plus 4y. Now the 2y squared differentiate into 4 because we bring the power down, we multiply the 2 by the 2. We differentiate y, so we get dy by dx, and we have a y left over, y. So I'm going to make that nicer. 4y dy by dx. And then 18, of course, will differentiate into 0. So when we differentiate this equation, we get the equation 2x plus 4x dy by dx plus 4y plus 4y dy by dx equals to 0 because we differentiate the 0 remains. So I'm going to rub this all out and write the derivative of this just so I have a bit more space. In fact, I'm going to rewrite it out over here. So 2x plus 4x dy by dx plus 4y plus 4y dy by dx equals to 0. So I'm going to minus the 4y and the 2x because now we're going to try and isolate the dy dx. So we have a function for the derivative of this curve, and with that derivative we can find the stationary points of the curve, stationary points on the curve. So that'll be 4x dy dx plus 4y dy dx equals minus 2x minus 4y. We'll factorize the dy dx out. For dy dx, 4x plus 4y equals minus 2x minus 4y, and then we'll divide by the 4x plus 4y, so we just get an equation for dy dx. Minus 2x minus 4y plus 4. And of course we can simplify this into minus x minus 2y over 2x plus 2y. So now we have an equation for the gradient of the curve. And we know that the stationary point will occur when the gradient of the curve equals to 0. So that means when dy by dx equals 0, then we have a stationary point. So we're going to make minus x minus 2y over 2x plus 2y equals to 0. We can times by the denominator, so we'll get minus x minus 2y equals to 0. And we'll get x equals minus 2y. Because we'll bring the minus 2y on that side, and then we can times by minus 1, or we can just plus the x onto that side, and we'll get x equals minus 2y. You know that x equals minus 2y when dy by dx is equal to 0. We're going to substitute all of this. We're going to substitute x equals to minus 2y into the original equation. So when we do that, we're going to get minus 2y squared plus 4 lots of minus 2y times y plus 2y squared plus 18 equals to 0. Now let's expand this equation. That turns into 4y squared plus actually minus 8y squared plus 2y squared plus 18 equals to 0. So we get minus 2y squared plus 18 equals to 0. And we can write this as 18 equals 2y squared. We can divide through by 2, so we get 9 equals y squared. And that's quite nice because square root plus minus root 9 equals y. Therefore, y equals plus or minus 3. So now we know that y equals plus or minus 3. We can substitute into that. We can substitute that into our equation over here to find the corresponding x value. So we can write when y equals 3, x equals minus 2 lots of 3 equals minus 6. So one set of coordinates, one stationary point will be minus 6 and 3. And when y equals to minus 3, x equals minus 2 lots of minus 3, which is 6. So another stationary point will be 6 and 3. Those are our two answers for this question. I hope you found the video useful. This video doesn't ask for the nature of these stationary points, which is something that we could have gone on if it was a larger question with more marks, but it didn't ask it this time. Thank you for watching.